Now, as we go into topic 3 of chapter 4, we're dealing with intersections, unions, and compound inequalities. Now, we're skipping some sections here, so to give you a little background of what these words refer to, you may have seen somewhere in your past what is called a Venn diagram. That's what this is here. These are Venn diagrams. And let's say we're talking about set A, and we're talking about set B. Now, in set A, there is numbers, let's say 1, 2, 3, 4, and 5. And then we have 6, 7, 8, like so. And you might say, well, what are the elements in set A? Well, 1, 2, 3, 4, and 5. What are the elements in set B? 4, 5, 6, 7, 8. And you might say you're noticing something, that in the numbers 4 and 5, they're in set A and in set B. So this would be your intersection here. The elements in the intersection are 4 and 5. And we sometimes would just shade that in a little bit and say that's the area of intersection. Now, as we look at the words, these are the official math words, there are some English words that also relate to them. In the word intersection, we're thinking of the word and. Now, this is used often in common language, but when it's used officially in math, it relates to this. It's an intersection. And in union, the key word that we refer to is the word or. And then we'll talk at compound inequalities as we go on. So another thing too before we go on is background. When we are coming across a mathematical statement and they're referring to an intersection or and is used, the symbol for intersection is this. It's sort of like an upside down U. And the symbol for union is like an upside down U, but without that other little line there. So this is an upside down U. In fact, we see it right there. There's the symbol for intersection right there. And then a little later we see the symbol for union right there. And we'll get to this as well. So this is background of what we'll be doing. And I'll leave that there for a few moments anyway. Let's do this first example. It says find now the intersection of these two sets. So imagine that these numbers are in this circle of the Venn diagram. And these numbers are in this circle. So what we're looking for here is which numbers are in both. Well, there isn't a 3, there isn't a 5, there isn't a 7, but we see 9 is in this set and it's in this set. And we see 11 is in this set and in this set. So we would say the intersections of this would be, and in roster notation, 9, 11. Now, we are changing from just general background of these words now to its use in graphing. So I'm going to give you some background on that as well. Now, before we go on to letter B, I'm going to give you some background on symbols that are needed to graph inequalities. So let's look at this first one here where we say x is greater than 2. So on our number line, I have 2 for all of these examples. How would I indicate and graph on a number line that x is greater than 2? Well, since we only have the greater than sign, is 2 included in the set of numbers if it's greater than 2? And the answer is no, it's not included. So what we do then is we put a parenthesis at 2, and I'm a little bit off there, but it should go right through that line, and darken this and align this way. So this is the graph of the statement x is greater than 2. The parenthesis indicates that 2 is not included in the set. Now as we look at this one, we have x is greater than or equal to 2. Now 2 is included. So how is this changed? Well, it changes from a parenthesis to a bracket. The bracket at 2 indicates that 2 is included. And as we look at this one, it says x now is less than 2. 2 is not included in the set, but since it's less than, it's going to be a parenthesis facing left and looks like so. And this one is similar to the one up here, but x now is less than or equal to. So 2 is included in the set, so we use a bracket. Now, another thing we often use when we write this is what we call interval notation. So what would be the interval notations for each one of these? Well, this is starting at, but not including a 2. So when we put it in interval notation, we just pretty much take it right from the graph. We're going to put a parenthesis, the number 2, comma, and say it goes on to positive infinity. Now this one, we're going to use a bracket, 2. Again, it indicates 2 is included in the set, and it goes to infinity. And this one is coming now from negative infinity, going up to 2, but 2 is not included. And this one is from negative infinity up to 2, and because of the bracket, we put a bracket there, 2 is included in the set. So as a little bit of background, we did some of this in like section 4.1 that we're not reviewing. So here is the review. If you need to, pause it, put this in your notes. This is good reference material, because now as we go to graph these, what we do is, first of all, identify what do we have here. Well, it has the word and, so this is an intersection. We are wondering what it looks like on a graph. So first I would put it in a form I'm more familiar with. I'm going to say x is greater than, reading it this way, -2, and x is less than 7. This is in the form. So often what we do with something like this is to build up by plotting this on a graph. So this is x, and let me just put a little line right here. This is going to be where -2 is, and we're saying x is greater than -2. So I'm going to plot that. Now I'm just going to use a parenthesis, and it's going to be a line going this way. So this is the graph of this first expression, inequality. Now on this line I'm going to do this one. X is less than 7. So 7 is right about there. And we're saying x is less than 7. So I'm going to put a line this way. Now, since this is an intersection, what we will project on our final line, which will be the intersection of this, is that we need a -2 and we need a 7. It's where these two overlap. So it starts here at -2 with a parenthesis, and it's going to go up to 7 with a parenthesis facing that way. And then that is my graph of letter B. And in a way you could have written it -2 is less than x is less than 7. This is sort of in the form of a compound inequality where x is in the middle and there's a value on either side. So this would be intersection because it's where the two inequalities overlap. And then in interval notation, this would be right from the graph, a -2, a 7, parenthesis. Now don't get this mixed up with an ordered pair. It looks like that, but it's actually interval notation. So we need to be cautious about that. All right, I'm going to clear this up so I have some room because I'm going to work on letter C now. So the first thing we have to do is solve it. Let me write it out here. And I know you're writing it out as well. Now we want to solve what x is in this compound inequality. And the way we do it is we start removing things. And from really old days, we used the technique of subtracting a 1 from here. That would make this a 0. But we'd have to subtract 1 from there as well, and 1 from there. So what we're doing is we're isolating the x term in the middle. So this now becomes a 6 is less than or equal to 3x is less than 15. Notice we have different types of inequality symbols here. Now, as we did in the past, when we have 3x and we want to get x by itself, we're going to divide by the numerical coefficient of x, which is 3, but we have to do it to each term. So this then becomes 2 is less than or equal to x is less than 5. So when we plot this on a number line, it's just a matter of putting the numbers we're interested in, a 2 and a 5, And in your homework logs, this would be, and in your notes, how you would keep things. This is your record of what you're doing. And then what symbol will you use here? Let's change colors too. Well, you're going to use a bracket because the 2 is included in the set. And then here you're going to use a parenthesis because the 5 is not included. Now that would be your graph. An interval notation would be a 2 and a 5, but a parenthesis. Interval notation comes right from the graph. Okay, that was letter C. Now we have an AND, which is again intersection, but we have to solve each of these inequalities. Let me put them up over here for you. So to save time, and we may pause the tape to copy some of this down, I've written this up here. Now I'm going to transpose this to the other side. It becomes a positive 10 on the other side, positive 4 I should say. Let me correct that. That's better. The negative 4 in an equality, when we just transpose it, the sign changes, and we have a negative 14, a positive 4 gives me a negative 10. So there's one of my inequalities solved. Now I'm going to take my positive 25 to the other side. It becomes a negative 25. Add those or subtract and I get this. Then I'm going to divide both sides by 2. And I get x now is greater than or equal to negative 11. Some of you may recall that every once in a while we have to change the direction of our inequality signs. And that rule was only if we divide or multiply by a negative, which we are not doing here. So the sign stays the same way, doesn't reverse. Now, when we plot this on a graph, our two inequalities, we have x is greater than or equal to negative 11. I'm going to put that right over here. And it looks like that. And then I have this one, x is greater than negative 10. Well, that's right here. So I put that. And what are we asking for here? We are asking for an end. So this is an intersection. So where do these overlap? Where's the intersection? And the answer is, it starts here at a negative 10 and looks like that. We're using a parenthesis because this is not including a negative 10. We're looking for, in a sense, the overlap of these. So again, a little bit complicated, but hopefully as we do it this way, and you take notes on it carefully, you can see when you do your practice and later your quiz bee, and then later your test, if you get one like this, this is how it's done. And this one's just a little more complicated, and I'll set that up too. Now, once again, we're just going to solve this and solve this, and the word "and" indicates it's an intersection. So here I'm going to transpose the negative 1 to the other side. It becomes a positive 1, giving me a negative 3. Dividing both sides by 3, I get x is less than negative 1. Then I'm going to transpose my 12 to the other side. It becomes a negative 12 there. This leaves me with a 5. Divide both sides by 5. That leaves me with a 1. X is greater than 1. So there's x is greater than 1. There is x is less than negative 1. And as I look at that, is there any intersection? And the answer is no. So when there is no intersection, we say it is an empty set. And we use this symbol, or we can sometimes use braces with nothing in it. That is, there is no intersection. It's an empty set. Okay, we're going to go on now to look at union of these as we continue our work. Now, as we do our union, we use a bracket, well, a brace, I should say, for roster notation, and we just list all the members. So we list 4, 6, 8. Now 8 is found in both, so we don't write it again. 9, 10. So that is our union. We're just including everything. Okay? Now let's do some graphing as we continue. We're going to put this on a line. And the numbers we're interested in are 7. Well, let's put the 4 first, and then the 7. Now, since it's an OR, this is a union, and we're saying that X is greater, reading it this way, X is greater than 7. So we're going to use a parenthesis. X is greater than 7. And now X is less than 4. Parenthesis this way. And we have that as our graph of an inequality. And you might say, how would I write that in interval notation? Well, we're using that as well. So where is this coming from? Well, it's coming from, let me write it over here, negative infinity up to 4, parenthesis. And then here's where we use this union symbol, starting again at just beyond 7, going to positive infinity. You'll see some of this down here. Oh, they are actually showing it this way here. All right, so again, you're going to need interval notation because I see that in the answer down there. Okay, let's take a look at letter C now. And first we have to solve it, so I'll set it up for you. I'll put them over here and I'll do it live so you can see how it's done. So the 2x is going to stay there. This is going to be transposed. It becomes a negative 5, so this is less than or equal to negative 12. And then divide both sides by 2. And we get then x is less than or equal to negative 6. All right, now for this one. 2 ways to do it. Because I'm going to eventually have to divide by a negative 6. In fact, I'll do it that way, just to show you. So this 12 goes to the other side as a negative 12. So I now get negative 6x is less than or equal to, this is going to be a negative 4. So on this side, it becomes a negative 12. 8 minus 12 is a negative 4. Now to isolate and get a positive x, I have to divide by a negative 6. When I do that, I have to reverse the inequality sign. And keeping in mind it's a negative 6 on both sides, so this becomes a positive 2/3. So there's my answer, and now I have to graph them. So I've made a number line, and on this number line, the numbers I'm interested in is a negative 6 from there, 2/3 from there, and what does it say? Well, it says x is less than or equal to negative 6. So for this one, I have to put a bracket facing left. That's this one. And for this one, it's going to be a bracket facing right. And since this is a union, that's fine. And I just put it in interval notation now, from negative infinity up to negative 6, bracket, and then union from 2/3 to positive infinity. There's the solution, there's the graph, and there is interval notation. Lots of stuff going on here. So it's already 27 minutes, so I will pass up doing these next two, which are going to be very similar to what we've already done. They are OR, so they are union. Let's go on to number 3, which is use interval notation to write the domain of this function. Now, when we do something like that, we cover this a little bit. We have f of x, which is function notation. Remember, this could be equal to a y as well. The square root of x minus 3. In fact, I think we did this one. We just take what is under the radical, because you can't have any number under the radical that is less than 0. So you then write x minus 3 is greater or equal to 0. And solve for that. You get x is greater or equal to 3. And then the interval notation of that is that, well, if you graph it, let's just do the graph for a moment. It's going to be 3, bracket, like so. There's the graph. So interval notation of this is that bracket, right from the graph, 3, comma, infinity. And I believe that's what they have here. Let's take a look. Oh yes, right down there. Good. I like it when we have that. And then let's take a look at this one too. And that's a combination as well. And on this last one, we have 2 radicals. And keep in mind this is and, so intersection. So we equate this to 0, this to 0, solve each one. And I get here x is greater than or equal to negative 1/3, and x is greater or equal to 1. Well, notice it has to be an intersection, so it's where the 2 combine. Now, if I, in blue, do this one, it's going to look like that. And if in black, I do this one, where do the black and red intersect? Well, they start here. So our domain then of this, because it's an and, would be the intersection, which starts here, and we can just see it in our answer there. That's because it's intersection. We don't count this part here. We did in solving, but when we put it there, we realize this is the answer right there. Okay, well, we ran over a little bit over 30 minutes. A lot of good stuff going on here.